In this last section in Chapter 4, we're going to be looking at how to use the counting principles we talked about in the previous section to form probabilities. Remember that probability, theoretical probability, is the number of ways an event can occur divided by the total in the sample space. So that's the idea that we're going to be using for this section. A parent-teacher committee consisting of 4 people is to be formed from 20 parents and 5 teachers. Find the probability that the committee will consist of 2 teachers and 2 parents. Assume the selection will be random. So when we work these problems, we have 2 things we need to count. We need to count the number of ways an event can occur and the number of different simple events or outcomes in the sample space. So for this problem, we want 4-person committees with 2 parents and 2 teachers. So we have to calculate the number of 4-person committees with 2 parents and 2 teachers, and we're going to divide that by the number of 4-person committees with no restrictions. The number of 4-person committees that we can form, the total number of people, we have 20 parents and 5 teachers. So for our 4-person committee, N is going to be 25. We're going to take them all together. We don't care if they're a parent or a teacher. We throw them all in the same pot and we draw 4 names out. Does the order matter when we're creating a committee? Does it matter if I'm picked first for the committee or if I'm picked third? If the other 3 people are all the same? It does not matter. We're still one 4-person committee, no matter what order we're chosen to serve on the committee. So this is a combination because that ordering does not matter. The order in which I choose each person on the committee is irrelevant. So in the denominator here, I'm going to do a combination of 25, choose 4. 25 total to choose from, and I'm taking 4. Because on the top, we have some restrictions. We have some very specific restrictions. I want 2 parents and 2 teachers. So for the 2 parents, I have 20 total, and I'm choosing 2 of them. 2 parents on a 4-person committee, but I have 20 total parents, and I'm taking 2 of them, only 2 of them for the committee. And then for the 2 teachers, I have 5 total teachers, and I'm taking 2 of them. So in order to count these together, if we have one number of ways of doing something and another number of ways of doing something, then to do those things together, that's our multiplication axiom. So we're going to multiply them together. So 2 parents, we have 20 combination 2. 2 teachers, we have 5 combination 2. We're going to multiply between them. And that's how we would count the number of 4-person committees with 2 parents, 2 teachers on the top, and the number of 4-person committees from everyone on the bottom. At this point, go ahead and pull up Excel or Google and let's calculate these combinations. And I'm going to do this separately just so that we can see the numbers and how big they are, and then I'll divide them at the end. But you can combine this all in one step. You just have to be careful and use parentheses. Okay, so I'm going to set up some labels. And let's make this a little bit bigger. If I go up here and I double click, I don't have to draw out with my mouse the size of the cells, the columns. I can come up here and just double click and it automatically adjusts to my text. And that's in Excel. I think Google does the same thing. Number of 4-person committee with 2 teachers and 2 parents. So we'll do combination equals combination. I did parents first on the paper, so we'll do 20 parents, choose 2 of them, times a combination again, 5 teachers, choose 2 of them. So the number of ways of choosing parents, the number of ways of choosing teachers, and we multiply them together. 1,900. The number in a 4-person committee, this is just a straight combination, 25 total people, choose 4. 12,650. The probability, I'm just going to use what's up here. Numerator divided by denominator. So the number in my event divided by the number in my sample space. And we get 0.150. We had 1,900 divided by 12,650. And when we did that division in the spreadsheet, 0.150 probability. Now this is an approximate probability. We are rounding. So in mathematics we like to use those curvy lines instead of straight lines for equals. This just means approximately equal. There are 2 more examples with the same setup for parent-teacher committees. 4-person committee with 20 parents and 5 teachers. So we'll do number 2 together, and then I want you to try number 3 on your own. I will give you the answer. The answer to number 3 is 0.451. See if you can use combinations to get that answer. But let's take a look at number 2. A parent-teacher committee consisting of 4 people is to be formed from 20 parents and 5 teachers. Find the probability that the committee will consist of all parents. Assume the selection will be random. So our probability, we still have a number of 4-person committee on the bottom. On the top now we're counting a 4-person committee, all parents, no teachers. So in our denominator, we still have 25C4, exactly like we had before, because we still have that same setup of 4 people chosen from 25 total. Now for 4 parents, I'm going to set up a parents and a teachers similarly to before. How many ways can we select the parents and how many ways can we select the teachers? We have 20 parents total, and we're going to select all 4 of them from the parent group. So 20C4 there. For the teachers, we have 5 teachers, but we're choosing none of them. So we'll put 0 there. 5C0, anytime we have a 0 for a combination or a permutation, if R is 0, then our answer is 1. It reduces to 0 factorial, which will give us 1. So this just turns into a 1, not 0, a 1. There's only one way to choose no teachers, and that's to choose no teachers. The reason that I point this out, though, of why I'm putting both of them here, look what happens with the n's in the combinations and with the r's in the combinations. The numerator n's add to be the denominator n, and the numerator r's add to be the denominator r. It's kind of a cool little feature with these probabilities. So if we calculate this out, 20C4 over 25C4, that teacher part just reduces to 1. Now this is from problem 1, and I'm just going to make a change to do 4 parents this time, and just change this combination, 20 parents, choose 4. I can put the teachers if I want to, combination 5, choose 0, but it's just going to give me 1. So if I hit enter, 4,845 in my numerator, denominator stays the same, and my probability is 0.383. See if you can try number 3 on your own. Finding a committee of 1 teacher and 3 parents. I've given you the answer so you can check. If you want the step-by-step, go take a look at our static record on the OneNote.